Hi, welcome back. We're going to work on factoring, but to be quite honest, I want to first work on multiplying binomials. I know many of you learned how to multiply a binomial, something with two things, two terms here, times something with two terms, by making these arches. So you'd go 2n times n gives you the 2n squared, and the 2n times the 6 gives you the 12n. The 3 times the n gives you the 3n, and the 3 times the 6 gives you the 18. Put the two middle terms together since they're like terms, and you got that. I know some of you might have also have done a box with it, where you would say it's two things by two things. You'd write one of them at the top and one down the side and fill that in. That's fine too. Okay, I just want to show you another way of doing it that might become helpful as we move on. If you're taking 2n plus 3 times n plus 6, you need to take the 2n times this thingy in parentheses and also the 3 times this thingy, which is what we did up here. We took the 2n times that guy and then the 3 times both of them. However, another way of writing it is like this. So you're taking the 2n times the whole thing, and then the 3 times the whole thing. And then distribute it. 2n squared and 12n, 3n and 18, middle terms still go together. So it is the same answer, just another way of thinking about it. So let me show you something with factoring that kind of resembles this. So if we're going to go with, it's called factoring by grouping, which means we're trying to make it look like this crazy line. Now I'm going to start with some real easy ones, and to be quite honest, you may be like me and think, lady, this is not the way I would do these problems, and that is okay. I personally don't do these easy problems this way either, but it kind of helps me go on to the next section, which is a little tougher. So you want to still do the factoring, maybe how you learned it in Algebra 1, where you think, what numbers multiplied together give you this last term, but add to give you this middle one. And the numbers that multiplied together give you 20, but add to give you 9 are 4 and 5. So I'm going to bring the first term down, and instead of writing that as 9x, I'm going to write it as 4x and 5x, because it's the same thing. Sometimes teachers may have said, I'm going to split the middle term. Then I want to look for a GCF in the first term, which the number or the factor that I could take out would be an x. If I take an x out of both of those, I would get an x plus 4. Then I think, what can I take out of both of these or divide evenly into them? A positive 5. And then you will notice that this term and this term have an x plus 4 in common. I usually put what they have in common first. And if I pull that out of each, I'm left with the x plus 5. Now, you might be thinking, hey lady, I already knew the numbers that multiplied together give me 20, but add to give me 9 are 4 and 5. I could have gone right here right away, and you are correct. All right, and in fact, that's what I do, but I want to make sure that you could carry this method onto harder ones. Let's do another one here. Same idea, but again, these are like the easy one because our lead coefficient is a 1. So what numbers multiplied together give you 20, but add to give you negative 9? This time, it would be negative 4x and negative 5x. And then you look, what can I take out of the first two? I can take out an x. If I do, I'm left with x minus 4. What can I take out of both of these? Now, I would take out a negative 5, or divide a negative 5 into each one, because when I do that, I would get an x minus 4. And your goal is for what's in parentheses to be the same. And when I do, it is an x minus 4. And then there would be an x minus 5 remaining. Again, you might say, lady, I could have gotten that right away. Okay, 2 more just to make sure you'd be okay with the last term negative. What numbers multiplied together give you negative 20 but add to give you 8? Those numbers are 10 and negative 2. So instead of writing that as 8x, I'm going to write it as 10x and negative 2x, and everything else will stay the same. Then what can I take out of the first two? I can take out an x. What can I take out of the next two? I could divide a negative 2 into both of those. And I know you are surprised that what's in parentheses is the same. I write that first. And then what's left, if I pull that out of each one, is an x minus 2. Again, you could go right from here to there if you would like. I'm not going to do this one. So that right there is the simple ones. But now let's do a little trickier ones where you may find that you like this factoring by grouping. Okay, so these are what I call the trickier ones because the lead coefficient is not a 1. Okay, now here's what I advise that you do. You need to do one extra step in these. You need to multiply that number by the following one. The A value by the C value is what they call those. 3 times 2 is 6. You don't have to write it down. I do because I like to see things. Then you want to think, what numbers multiplied together give you this new number 6, but add to give you 7? Think hard enough, I can think of 6 and 1. So I'm going to, again, bring that down, but this middle term I'm going to split into 6 and 1. And I'm going to bring down the originals. So everything looks the same except for the 7 is now a 6 and a 1. What am I going to take out of the first two? Well, I think I can divide a 3 and an x into both of those. If I do that, I'm left with an x plus 2. Then I look at the last two and I think, ooh, what can I take out? Well, if I don't really see a GCF or something to take out, which I don't, I'm going to just take out a 1. Because if you divide a 1 into them, it doesn't really change. This x plus 2 would still stay x plus 2. And you will notice that, again, I got the same thing in parentheses. When that happens, I'm in great shape. I put that first, and then what's left goes in the parentheses next to it. So again, it's the same steps as before, but I must multiply this over here. Now, to be honest, I could have done that over here. There was a 1, I could say 1 times 20, but we just don't bother multiplying by 1 because it doesn't change the value. Okay, let's try another one. I'm going to take 9 times 2, and I need to think of 18. So numbers that multiplied together give me 18, but add to give me negative 9. Maybe negative 6 and negative 3. So I'm going to rewrite everything exactly the same. Negative 6 and negative 3 is still the same value as that. And again, it doesn't matter which one I write first and which one I write second. It will always work. And I look at the first two and think, what can I take out? See, it looks like I could take out a 3x. Yeah, I could take out 3x. And when I do that, I'm left with a 3x minus 2. Then I'm going to look here and think, what can I take out? And I want it to be this. When I take something out, I want that to be left. So I might go, well, I really can't take anything out, but I'll need it to be a positive 3x, so I'm going to take out negative 1. Whatever you pull out, make sure you put the sign with it. If I divide a negative 1 into each of those, I'll get 3x minus 2, which is what I need. I need what's in parentheses to be the same. So that what is the same is 3x minus 2, and then a 3x minus 1 is left. And if you're like, hey, wait a minute, I don't get that, you could always multiply it back out. But you can see here, if I multiplied it back out, I would get that step up there. So here's my final answer for that second one. Let's go to our last one. Again, 3 times negative 5 is negative 15. So that's what I'm thinking. What numbers multiplied together give you negative 15, but add to give you 14? Well, if they multiply together to give you a negative, one would have to be positive and one would have to be negative. Bring down the 3x squared. I think I have it. 15x minus 1x. So a positive 15x and negative 1x would give me that. Then I think, what can I take out of the first two? I could take out a 3 and an x. When I do, I'm left with x plus 5. What can I take out of the second two? Maybe a negative 1. And if I divide a negative 1 into each one, I'd get an x plus 5. And again, you might be thinking, why did he take out a negative 1? I might have just taken out a 1. Well, if you take out a 1, the signs would stay the same, and I need them to be positive. And because my whole goal is for whatever is in parentheses to be the same, which is in this case was an x plus 5. If I pull that out of both, and that is my factoring by grouping, which again, if we go back here, if you want to just think of what numbers multiplied together give you 20, but add to give you 9, and you can go right here right away, that is fine. However, you may not do that here because you can't think what numbers multiplied together give you 2, but add to give you 7. That little trick does not work when this coefficient is not a 1. So if you want to stay consistent with how you do it, this new method here with grouping works on all of them. Thank you, factoring by grouping.